Hello guys, welcome to PM Networking. Guys, as I had told you that in part 2 of lab 2, I will configure OSPF virtual link and BFD for OSPF. So today in this video, we are going to configure OSPF virtual link and BFD for OSPF. So my lab is here. You can see guys, this one is my lab. And on all devices I am running some loopback. So just see, suppose on router 1, as you can see, router 1 is member of two area 0 as well and area 10 as well. So here I will create two loopback. I will advertise one loopback in 0 and one loopback in area 10. Here on router 2 I will configure only one loopback. Here also I will configure two loopback because you can see router 3 is connected with two area. In the same way on router 4 I will create one loopback, that will be 4.4.4.4. On router 5 I will create two loopback. And IP addressing, you can see between router 1 and router 2 my network is this one. Between router 1 and router 3 my network is this one. So IP configuration will be same as we discussed in last class. Okay, so first of all let me show you the configuration guys. Here you can see these are IP configuration. On router 1 I am running, I have created two loopback. One is loopback 0 and other one is loopback 1. On loopback 0 I am running network 1.0.0.0 and on loopback 1 I am running network 11.0.0.0. In the same way on router 2 I am running single loopback, only one loopback. On router number 3 again I am running two loopback. On router number 4 I am running one loopback. On router number 5 I am running two loopback. On router number 6 again I am running a single loopback. On router 7 also, and on router 8 also I am running only single loopback. After that, task number 1 is configure OSPF in area 0 between router 1, 7 and 8. Beside the physical link, enable the loopback 0 interfaces of all three routers in area 0. So here in area 0 we will advertise the loopback 0 of all these three router 1, router 7 and router 8. Loopback should be advertised with the interface mask. So you have to change network type on loopback as well. As you know, by default OSPF network type on loopback interface is loopback. So you need to change the network type on loopback interface also, right? So we will run one command on interface, that will be IP OSPF network point to point. After that, hard code the router ID based on the following. So on router 1 you will configure 0.0.1 router ID, and on router 7 this one will be the router ID, and on router 8 this one will be router ID. Okay, so first of all let me perform task 1. So here I am going to configure router 1, router 7 and router 8, and I will advertise all loopback 0 interfaces of all these three router in area 0. So let's begin from router 1 and let me show you IP configuration guys. First of all, so IP interface brief, exclude unassign. I don't want to see an assign interface, so it's showing. So here you can see I am running two loopback, right? And these are physical interfaces, IP addresses, right? Now I am going to configure OSPF area 0. So router OSPF 1, router ID is 0.0.0.1, and then network will be 192.1.17.0, 0.0.255, and area 0. Network 192.1.18.0, right, between router 1 and router 8. And after that we need to advertise loopback interface. So IP address on loopback is 1.0.0.0, 0.255, 255 area 0. And if you will verify network type now, here Cisco IP OSPF interface loopback 0. Here you can see network type is point to point. Actually, I have already run this command on interface in last time, right? In last practical. That's why it's showing point to point. But I will, if I will remove this command from loopback 0, no IPOSPF, no IPOSPF network point to point. Okay, just wait. Network, sorry, IPOSPF network point to point, and let me say no. Right, and now if you will verify, so IP interface loopback, so IP OSPF interface loopback 0, here you can see network type is point to point. Now this time this router will advertise their loopback 1 network with /32, right? So here we need to change network type on loopback 0. So IP OSPF network type is point to point. Right, now let me configure router number 7. So where is router 7? Here it is. Enable config T router OSPF process ID 1 and router ID is 0.0.7 network 192.1.17.0 0.0.255 and area 0, right? Then network 7.0.0.0 0.255.255.255 and area 0, exit interface loopback 0, IP OSPF network type is point to point. Let me save the configuration. Now let me configure router number 8. Config T router OSPF 1, router ID is 0.0.0.8 and network 192.1.18.0 0.0.255 and area 0, network 8.0.0.0 0.255.255.255 and area 0. Now you can verify neighborship as well. So IP OSPF neighbor, so you can see neighbor is router 1 and you can verify routing table as well. So IP root OSPF, so here you can see 7 network, right? So this router is receiving 7 network with /8 or /32, so with /8, right? In the same way on router 7 also you can verify. So IP root OSPF, there will be 8 network 8.0.0.0/8. Fine. So task number 1 is completed, right? Here I have configured OSPF area 0 between router 1, 7 and 8. Now let me check task number 2. Now configure OSPF area 10 between router 1, 2 and 3. So between router 1, 2 and 3, here 1, 2 and 3. So on this 3 router I will configure what area 10. Beside the physical links, enable the loopback 0 interface of router 2 and router 3 in area 10. So as you know, right, on router 1 loopback 0 is advertised. I have advertised in area 0, right? So here in area 10 I will advertise loopback 1, but on router 2 and router 3 I will advertise a loopback 0 in area 10. Okay, so okay, is there anything else there? Let me check again. On in area 10, router 1 loopback should be enabled in area 10. Loopback should be advertised with the interface mask and hard code the router ID, this one. Okay, so again go to router number 1 and here config T router OSPF 1, and now network is 192.1.12.0.0.255 and area this time 10. After that network 13 here, right, and then network 11.0.0.0 which is running on loopback 1 and area 10. Okay, now let me save the configuration and let me configure router number 2. So here is router 2, go to config T. I have already configured IP address, so IP interface brief exclude unassigned, right, and I am not running any protocol, so IP protocol here you can see. So go to config T, router OSPF process ID is 1, network, before running network command router ID 0.0.2, after that network 192.1.12.0.0.255 and area 10, network 2.0.0.0.0.255.255.255 and area again 10. Let me save the configuration and here you can verify. So IP root OSPF, right, 7 network, 8 network, 11 network, right, 11 network which is running on router 1. Okay, yes, so fine, everything is okay till now. Now let me configure router number 3. Here we need to run one more command on router 2, that will be on interface loopback 0. On interface loopback 0 I will run IP OSPF network, network type is 0.2 point, right. Now save the configuration and now let me configure router 3. So here it is, enable config T, router OSPF 1, router ID 0.0.3 and network 192.1.13.0.0.255 and area 20. After that network 3.0.0.0.255.255.255 and area is 10. I am advertising loopback 0 in area 10. Fine. After that interface loopback 0 IP OSPF network type is 0.2 point. Fine. So task number 3, set 2 is also completed. So IP root OSPF, you can see the routing table of router 3. Yes, router 3 have all interior prefixes in their routing table. Now task number 3 is configure OSPF area 20 between router 3, 4 and 5. So here between router 3, 4 and 5 I am going to configure area 20. So first of all let's begin from router 3. Again router OSPF process ID is 1 and this time network 192.1.34.0.0.255 and area will be what, 20. Then network 33.0.0.0.255.255.255 and area is 20. So this one is loopback 1. I have advertised this interface in area 20. Fine. Now interface loopback 0 and IP not 0, it's 1, or you can interface range loopback 0 to 1. You can run the command on both interface at the same time. So IP OSPF network type is point to point. Fine. Now I am going to configure router number 4. So let me take access of router 4, guys. Here it is, and this enable config T router OSPF process ID, router OSPF process ID 1, network will be 192.1.34.0, 0.0.255, and area will be 20. Network 192.1.45.0, 0.0.255, and area is again 20. And network 4.0.0.0, sorry, 0.255.255.255, area is 20. Interface loopback 0. IP OSPF network type is point to point. Let me save this configuration and let me configure router 5. So here it is, enable config T router OSPF process ID is 1, and here network 192.1.c between router 4 and 5 I am running 45.0, 0.0.255, area will be 20. I think I have forget to run one network command on router 4. I think so. So run section router OSPF. Here let me check. So no, I have run this network as well. Okay, network this one, and on router 5, is there any more interface in area 20? No, there is one loopback interface. So network 5.0.0.0, 0.255.255.255, and area 20. Interface loopback 0, IP OSPF network point to point. Right. Okay, so this task is completed. Let me verify the routing table. So IP root OSPF. So here you can see this router is not receiving routes of router 7, router 8, router 1, and router 2, because those are intra-area prefix, right? Inter-area prefix. So for that we need to create virtual link. So we will discuss that also. First of all, let me move to next task. Okay, and router ID. So I don't think that I have configured router ID on router 5. So run section router. Yes. So config T router OSPF process ID 1 and router ID is 0.0.5. So but now I cannot run. So clear IP OSPF process and say yes. And now you can run this command. Okay. Now so IP OSPF neighbor. Who is neighbor? 4.4.4. Okay. So let me configure router ID on router 4 as well. I have forget to run this command. So router OSPF process ID is 1. Router OSPF process ID 1 and router ID is 0.0.4. Now do clear IP OSPF process, say yes, and now you can run this command. Okay, let me see. Okay, just wait. Clear IP OSPF process, say yes, and so IP OSPF neighbor. Now you can see everything is okay. So let me move to next task number 4. Configure a virtual link between the appropriate device to allow area 20 to communicate to the rest of the network. So here you can see area 20, right? Area 20 cannot communicate with area 10 and cannot communicate with area 0 because this router 3 is not ABR router, right? So what we can do, we can create a virtual link between router 1 and router 3 because router 1 is connected to area 0 and virtually I will connect router 3 to area 0 so that this router will become what? ABR. And once this router will become ABR, this router will start sending prefixes of this area into this area and this area to this area, right? That means that will be inter area prefixes. So task number 4 is very simple. It is saying that configure a virtual link between the appropriate devices to allow area 20 to communicate to the rest of the network. So here you need to configure virtual link between router 1 and router 2. So first of all, I am going to configure virtual link on router 1. Go to config T. After that, router OSPF process ID is 1 and then area is 10. Virtual link. After that, router ID of router 3, it is this one, right? Now come to router number 3. Here it is. And now if you will check routing table, so IP root OSPF. So see, there is these prefixes, right? And if you will verify, so IP OSPF neighbor, you can see there is one neighbor with router 1 and one neighbor with router 4. Okay. So IP OSPF virtual link. So, okay. Right, but now this router 3 will not share these prefixes with router 4, right? You can see with router 4 which is present in area 20. So if here if you will run so IP root OSPF, here you can see there is no prefix. This router cannot communicate with router 7 or router 8, right? So on router 3 also we have to run one command, this command. Okay, here you will run in global configure mode, go to router OSPF 1 and again area 10 virtual link router ID of router 1 0.0.1. Now if you will check so IP OSPF neighbor, you can see guys, just wait, and now you can see there are two neighborship with router 1. One is virtually, here you can see interface is OSPF virtual link 2, right? And now you can check the routing table of router 4. So IP root OSPF. See here, right? Means now area 20 can communicate with any area. Fine. Okay. Let me move to next task. Next task is, this one is task number 4. Task number 5, configure OSPF area 30 between router 5 and 6. So between router 5 and 6, I am going to configure area 30 first. Go to router number 5 and say config router OSPF 1 network 192.1.56.0.0.255 and area is 30. After that, network 55.0.0.0.255.255.255 and area is again 30. Area is 30 and interface loopback 0 IPOSPF network 1 right. Go to router number 6. Enable config router OSPF 1. After that, router ID 0.0.6 and network 192.1.56.0.0.255 and area 30 and network 6.0.0.0.255.255.255 and area is 30. Area 30, right? Interface loopback 0 IPOSPF network 0.2. Done. So, but router 6 cannot receive prefixes of area 0, prefixes of area 1, so IP root OSPF. Here you can see there is only one prefix. So again, task number 6 is configure virtual link between the appropriate device to allow area 30 to communicate to rest of the network. Now here you need to configure virtual link so that area 30 can communicate with all other areas, right? All other areas network. So here you will create virtual link between router 3 and router 5. So router 3 and router 5 both router connected with same area, that is area 20, and router 3 is connected with area 0 virtually. So here I am going to connect virtually router 3 and router 5 so that area 30 can communicate with all other area. So go to router number 3 first and here router OSPF process ID is 1 and after that area, which area? Area 20 this time. Virtual link, after that router ID of router 5, this one, right? And you need to run one command on router 5. So this one is router 5, config T, router OSPF process ID is 1 and area 20 virtual link 0.0.3 which is router ID of router 3. Now you can see, so IP OSPF neighbor. So there is one virtual neighbor as well, right? Here you can see. And now you can verify routing table. So IP root right? Now this router can ping 7.7.7.7 or not. What do you think? Ping 7.7.7.7. So see guys, this machine, this router is able to ping, right? So now all network are reachable to each other. Let me check task number 7, that is last task. So configure now BFD between all routers in area 0. Okay, so you need to configure BFD in area 0 only, right? Configure the BFD interfaces interval to be 300 for sending and receiving. Okay, a neighbor should be dim date is the router misses 3 hellos, right? So okay, now I understand what we need to configure here. So I will configure on router 1, router 7 and router 8 in area 0, right? These router are member of area 0. So first of all, on router 1, go to interface E1/0, E1 slash, not E1/0, interface E1/2. It's 1/2 in area 0, right? After that, BFD and interval is 300. After that, mean RS 300 multiplier 3, right? Now go to router OSPF 1 and BFD. BFD all interfaces. Fine. Now you need to run same command on router 7 and router 8. So go to router number 7. Let me run same command very quickly here as well. Config T interface E1/0, E1/0, right? Yes. After that, BFD interval 300, mean RX 300 and multiplier 3, right? After that, router OSPF 1 and BFD all interfaces. Okay, let me save the configuration, right? And let me do same thing on router 8 as well. Enable config T router OSPF, sorry, first of all interface E1/0, BFD interval 300, mean rate 300 and multiplier 3. After that, router OSPF process ID is 1, BFD all interfaces. That's all guys, that's all. Now your lab, this part 2 is completed, lab number 2 is completed, right? This one was last task. So now in next video I will configure one new, I will create one new topology in eveng, right? And then I will show you the configuration, advanced configuration of OSPF and BGP. Okay guys, so that's all for today. If you like this video, please hit on like button. If you haven't subscribed my channel, please subscribe this channel. We will meet soon in next video. Till then, stay safe. Bye bye.